B is a chord of a circle with center O and radius 4 centimeter. So here we have a circle, and this circle we have a chord. AB is a chord with center O and radius is 4. Radius is 4. And AB is of length 4 centimeter. This is 4, this is 4, this is 4. And divides the circle into two segments. So this shaded region is the minor segment and the other region is the minor segment. Find the area of the minor segment. So here we have the direct formula which we can use directly. But first we have to know the length of the chord if we want, and the angle, because the angle is not known. See, in the question the angle is not given. So this is 4, and this length is given. This length and this length is given. It's because this is radius, and the chord length is 4 centimeters. So all the lengths are equal. When in a triangle, when all the sides are equal, all the angles are equal, that means this triangle is an equilateral triangle. Equilateral triangle. So what is the angle here in an equilateral triangle? Because all the sides are equal. All the sides are equal. So angles are 60 degree each. This is 60, this is 60, and this is 60. So now theta, the chord which subtend an angle at the center is 60 degree. Now the formula goes like this. See, r square radius square we have to write outside. Then we have theta by 360 into pi. Then we have to subtract sine theta by 2 cos theta by 2 from this. And this has come from where? This has come from, see, this is the sector. So the sector is simply, the sector is theta by 360. What is the area of the sector? Theta by 360 into pi r square. And we have to know the triangle. This is an equilateral triangle, whatever triangle. The area of the triangle in this case is nothing but root 3 by 4 side square. Root 3 by 4 side square. That is 4 into 4. So this root 3 by 4 will come from here. Sine 60 by 2 and cos 60 by 2. That is sine 30 and cos 30. So it is going to be root 3 by 4. And 4 into 4 is here. This is r square. This is r square. So this is a formula which we will apply everywhere. This is specific. This formula is specific for this triangle, which is the equilateral triangle. But you can generalize it for any of the case. So here we will put the values. R square is 4 square. So we'll write 16 here. Then we will write this theta as 60 degree. So you can just keep it like pi also if you want. Right? Pi. You can just put it like pi. So this is pi by 360, and we will bring this 16 inside pi, and then we have this r square. So r square is already out. So theta pi, and theta is what? It is 60 degree here. Minus root this. I'm using this generalized formula. So sine theta by 2 is, that is sine 60 by 2. So sine 30, which is half. And cos 60 by 2, cos 60, which is root 3 by 2. So we have 16, and then 6 are 36. This is pi by 6. Now bring 16 inside. So you get 16 into pi by 16 by 6 minus. Now this is root 3 by 4. Now this is root 3 by 4, 2 to the 4, and bring 16 inside. So do you get? You get 8 pi by 3 minus 4 root 3. This is the answer. And even if you do like this, you'll get the same one. A chord PQ. So here we have a chord PQ, and this is of length 12 centimeter. It subtend an angle of 120 degree here at the center of the circle. Find the area of the minor segment cut off by the chord PQ. Now you can directly use the formula, this one, pi theta by 360 minus sine theta cos theta r square. You can directly use it. But for this we need first of all, because the angle is given, so we need this radius also, and the area of triangle can also be known. But we can use directly the formula, so we'll try to use the formula, but only the radius part has to be known. Otherwise this angle is given 120 degree, so we just need to know the radius part, because we'll apply the formula directly. No, we'll not do that. That first we'll find out the sector, then we'll subtract the area of triangle. That we can also do, but this is the direct formula, so we'll use it. So here we have a triangle. In this triangle we drop a perpendicular here. So this hole is what? Because this is an equilateral, this is an isosceles triangle. This side is this side. That is, these both are radius. These both are radius, and this hole is your 120 degree. So this will be 60 and this will be 60, because the perpendicular of an isosceles triangle divides the angle, or it bisects the angle. It is an angle divided. The perpendicular is, and this hole is 12. So this will be 6. This will be 6. Now, in order to find the radius, if this is the triangle, what we can do? See, I'll use, because this is the perpendicular, this is the hypotenuse. So I'll use sine 60, which is going to be r by 6. This perpendicular, or you can say perpendicular upon hypotenuse. So it will be 6 by hypotenuse r. So sine 60, this is root 3 by 2. So root 3 by 2 will be equal to 6 by r. R will be what? This 2 into 6 by root 3, that is 12 by root 3. Now multiply root 3 in the numerator and denominator, you get 12 by 3 root 3. This root 3 will become 3. So 3 4s are 12. You get 4 root 3. Now we'll use the formula, that is r square, which is this 4 root 3 square. So r is 4 root 3 square. Then theta by 360 into theta by 360 into pi. Theta is 120 degrees. So 120 degree by 360 into pi, minus sine theta by 2 cos theta by 2. So whole theta we have to use 120 degrees. So theta by 2 will be what? 60 degree. So sine 60, we know sine 60 value is root 3 by 2, and cos 60, cos 120 by 2 is cos 60. Cos 60 is what? It is half. So what do you get? 4 root 3 square, 4 root 3 into 4 root 3. So 4 4s are 16, root 3 is 3. So you get 48 here. So this will be 48. And we have what? 120 by 360. So this is going to be 3. So we have pi by 3 minus root 3 by 4. If you want to take this inside, you can do it, because what you get here is, I'm just taking the LCM. So 4 pi minus 3 root 3 by 12. This is 48 outside. So it is 3 times, or 4 times, sorry. So the answer is 4 pi minus 3 root 3. So the basic thing was to find out the radius. Otherwise, you just have to use the formula. A chord of a circle of radius 14 centimeter makes a right angle at the center. Find the areas of the minor and the major segment. So here we have to find the major segment also. First we will find the minor segment, this one, and this we know the formula. This will directly use, that is theta by this minor segment area will be equal to, let me make it as mi, minor. This is theta by 360 into pi. So theta is 90 degree here. So 90 by 360 into pi minus sine theta by 2 cos theta by 2. Sine theta by 2, this sine 90 by 2, that is sine 45. Sine 45 is 1 by root 2, and cos 90 by 2 cos 45, that is cos 45 is also 1 by root 2. And then we have r square, 14 square. This is our first one. So what do we get? This is 4 times, you get pi by 4 minus this is 3 by 4. Okay, this is 1 by root 2, and so 1 by 2. This is 1 by 2. And you have 14 into 14, that is 196. So pi can be written as 22 by 7. 4 will be here. Bring 196 inside. Then you have 196 by 2. So what do you get? You get this has 154. This has 98. So 154 minus 98 is 56. Now this is the area of this smaller segment. So in order to find out the major segment, this whole means we have to take the area of the circle and just subtract this minor one. We'll get the area of the major segment. So what is the area of the circle? It is simply pi r square. Pi is 22 by 7. R is 14 into 14. So what do you get? You get 616. This is the area of the whole circle. And you have to subtract this to get the major part. So 616 minus the minor area part, this is going to be 560 centimeters square. So this is the answer. This is the major region area. A chord of length radius 14 centimeter, makes the right angle at the center, find the areas of the minor and major segment of the circle. So this is just to show that in other way also you can do. This is the another way to solve it. Coming to the next question, a chord 10 centimeter long. So here we have a chord which is 10 centimeter long, is drawn in a circle whose radius is 5 root 2. Find the area of both the segments. So here we have the same scenario. We have a triangle here. We have this as 5 root 2, this as 5 root 2 because these are radius. This, we drop a perpendicular, right? This whole is 10. So this will be 5, this will be 5 because this is an isosceles triangle. So this divides and this is 90 degree as well. These are the properties, and this angle are equal. So in order to find this theta will be what? I am taking tan theta. Tan theta will be, for this triangle, this will be perpendicular and this will be hypotenuse. So I will take sine theta. So sine theta is perpendicular, that is 5 by a 5 root 2, hypotenuse. What do you get? Sine theta as 1 by root 2. But you know this is sine 45. Is 1 by root 2. So this angle is 45. So this angle will also be 45. So this whole angle will be 90 degree. So we got the theta. Theta is 90 degree. Now we can apply the formula directly. So area will be what? Theta, this theta is 90 degree. So 90 by 360 into pi. You can take this 50, this r square. Our radius is 5 root 2. So r square is 5 root 2 square. This will be 25. Root 2 is 2. So 50. So you can just bring it 50 and multiply this with pi. So you can use 22 by 7. This is done. Now coming to sine theta by 2, cos theta by 2, sine theta. Theta is 90. Sine theta by 2, sine 45 by sine 90 by 2, that is sine 45. And cos will be same, cos 45. So it will be 1 by root 2 into 1 by root 2, which eventually comes to be 1 by 2. So when you solve it, this will be pi by 4 and this will be, let me directly write the value. This one will be 39.25 and this will be, of course, your 50 is inside. So you get 50 by 2 minus 25. So you get 14.25. And this is the area of the minor segment, this segment. So in order to find out the area of the major segment, you have to do what? You have to take the area of this whole circle and subtract this minor segment. So what is the area of the whole circle, which is pi r square? So it will be 3.14 into r is 5 root 2. So 5 root 2 into 5 root 2. So 3.14 into this 5 is a 25 and then root 2 into root 2 is 2. So you get 157 centimeter square. This is area of the whole circle and this is the area of the minor segment. So in order to find out the area of the major segment, you just subtract these. So 157 minus 14.25 and this is going to come as 142.75 centimeters square, and this is the area of the major segment, this one. A chord AB of circle of radius 14 centimeter makes an angle of 60 degree. Makes an angle of 60 degree at the center of the circle. Find the area of the minor segment of the circle. So here the same scenario is with us. Same scenario, but the angle is given as 60 degree. We'll take half, so I just said 30 degree. So we'll use the formula. So it will be r, the area will be simply the r square. What is the radius? 14 into 14, r square. Then we have pi, 22 by 7. Theta is 60 degree. Whole 60 degree you have to take. 60 pi, this pi by 360. And this minus sine theta by 2 cos theta by 2. Sine 30. Sine 60 by 2 cos 60 by 2. So sine 30 cos 30. Sine 30 is was what? 1 by 2. And cos 30 is root 3 by 2. And we bring, this will bring later. So this 14 into 14 is 196. So I'm bringing 196 into this is 6 is 36. So you get 22 by 7 into 6 minus this root 3 by 4. And here you bring 196. So you have to take root 3 as 1.732. So this will become 102.66 if you solve it, and this will become 84.87, and this is going to be 17.80. Find the area of the minor segment of a circle of radius 14 centimeter when the angle of the corresponding sector is 60 degree. So here we can use the direct formula. So we have a circle here, then the radius is also given 14 centimeter and there is a minor segment. Now here angle is given 60 degree. So if you use the formula, then you have to find out, because you can just subtract it or you can use the direct formula. So what we will do here is, we have already known the formula. But what is the actual science or technology behind it? Let me see that I can tell you the logic here. So what we will do, this is 60 degree. So we have a triangle and this is 60 degree. So this side is radius and this side is radius. So this angle and this angle will be 60 degree. So this triangle is an equilateral triangle. So if this is 60, this is theta and this is theta, I'll just tell you how we make it. 60 plus theta is 180 degree, because the sum angle of a triangle is 180 degree. Now take this 60 here, so theta is 2 theta is 180 minus 60, that is 120. So theta is 60 degree. This is how we got the angle here, 60 and 60. So when we got the angle 60, it's an equilateral triangle. When we have an equilateral triangle, we can say that this area of triangle, that is area of triangle, will be equal to root 3 by 4 side square, that is root 3 by 4 14 square. This is area of triangle. Now let us find out the area of the sector. We know the area of the sector is what? It is area of sector. It is going to be theta by 360 into pi r square. Theta we know 60, so 60 by 360 into pi r square. So pi you can use as 22 by 7, r is 14 into 40. Now this total sector, if we subtract this triangle, then we get the area of minor segment. So you have to subtract root 3 by 4, just 14 square. And this is nothing but the formula we used earlier. If you remember, theta by 360 into pi r square minus sine theta by 2 cos theta by 2 r square. This we have already seen. So this is how the logic works here. So when you just try to solve this one, you will get this one as 308 by 3, and this of course will be root 3 by 2 for root 3 by 4 14 square, that will be 49 root 3. So this is the answer. This is the way you have to approach this type of question. A chord of radius which is 20 centimeter, this is radius, a chord of radius. So there is a chord and there is a radius which is given as, this is 10. So 10 centimeter. So it subtend an angle of 90 degrees. So we have a circle and there is a chord and it subtend an angle of 90 degree. This is 90 degree. At the center, find the area of the corresponding major segment of the circle. So we have to find out the area of the major segment. The question here is somewhat different. We just don't have to find this area. Basically, we have to find out this area. I hope you got the idea. In this question, we have to find out this area. For that, what we will do? We will find out this minor segment area, or rather what we can do here is, we have a sector here with 90 degree. This sector is 90 degree. But what is this angle? 360 minus 90. So what is 360 minus 90? It is 270. So this is the angle 270 from here to here. So this is a sector again. It is also a sector with angle 270 degrees. So we can find out the area of this sector. Right? We have to find out the area of this sector. So for that, what we will do, we will use the formula directly. That is, now theta by 360 into pi r square is the area of this sector. But we are interested in finding the area of this sector. So we'll use 270 degree rather than 90 degrees. So 270 by 360 into pi into 10 square. This is going to come as 235.5. Now coming to this area of triangle, because area of triangle has to be known and we have to add the area of the triangle with this one. We need to add this. Then only we say this is the area of the bigger segment, major segment. I hope you got the idea. We have to add these two. So we have to find the area of this triangle also. So now coming back to the triangle. This is a triangle. Now the angle is, this is 90 degree. This is 90 degree. And the radius is given. So we have the radius as 10 This is also 10. So how to find out? Because in order to find the area of the triangle, we need half into base into altitude. Half into base into altitude. This is what the area will tell us. Okay. So half into base into altitude. See, this is 90 degree. This is 90 degree. So if I take this 90 degree, this will be 45 degree. This will be 45 degree. Why? Because these two sides are equal. These two sides are equal. So in order to get this side, or you can say half into base into altitude, this we already know. So there is another method which you see here, but I'll tell you a very short method. This is the base and this is the altitude. So half into base into altitude. We already have base and altitude. This is 10 and this is 10. So half into 10 into 10. Base into altitude. You don't have to go for this cos 45 or sin 45, etc. You already have, because this is 90 degree. For an angle, for a triangle with 90 degree angle, this is base and this is altitude. So just multiply this, half into 10 into 10, which is going to be 50. This is 50 centimeters square. So now we have this sector area. We have now this area also. Just add them so that you get whole of this area. So 235.5 added with 50 is going to give you 285.5. And this is your actual area. This is what is you are interested in. I hope you got the idea. This 50 we got from here. There is another method also. So there are two methods to find the area. But ultimately this area has to be added to this sector. The radius of a circle with center O is 5 centimeter. So this is 5 centimeter. This is 5 centimeter. Two radii, this is OA and OB. These are drawn at right angles to each other. So this is 90 degree. This is 90 degree. Find the areas of the segment made by the chord AB. So we just have to use the formula. And then first formula we'll try to find out for this one. This segment, and we know the formula. It is r square. I'll just write the values directly. R square is 5. So 5 into 5 r square. Then you have theta into pi by 360. Theta is 90 degree because it is given. Theta by 360 into pi. You already have this, so just make it 3.14 if you want. Then minus sine theta by 2 cos theta by 2. Theta is 90, so theta by 2 will be 45. So sine 45 cos 45. Sine 45 is 1 by root 2 and cos 45 is 1 by root 2. So what do you get? You get 25, and this comes to be 0.785. This is 1 by root 2 into 1 by root 2, that is 1 by 2. 1 by 2 is 0.5. So you have 0.5 here. So this becomes 25 into, this will be 0.285, and this gives you the area of the smaller or minor segment. It is called as, it will be 7.125 centimeters square. Now this is the minor one. In order to find the major one, just subtract this from the whole area of the circle. So area of the circle is pi r square. Pi r square 3.14 into 5 into 5, which is going to be 78.50. Now you just have to subtract these two. That is, you have to subtract this 7.125 from here. So 78.50 minus 7.125, and this is going to come as 71.375, and this is the area of the bigger one, that is major segment. Area will be always in squared unit. AB is the diameter of a circle. So this AB is the diameter of circle of center O. C is the point of the circumference. So C is here point on the circumference such that COB, that is this angle, is theta degree. The area of the minor segment cut off by AC. So the area of the minor segment, so this is AC. So area of this minor segment, that is this one, is equal to twice the area of the sector BOC. So this is the BOC, is twice. So what will be the area? We'll just equate them. There is nothing much we have to do here. So first of all, the area of the minor segment is what? See, first of all, this is theta. So what will be this angle? 180 minus theta. So this angle will be 180 minus theta. So in order to this AOC, this sector, in order to find out the area of this segment or this sector or this segment, sorry, minor segment, what we will do? We will use the formula directly. So this is r square theta by 360 into pi. What is theta? 180 minus pi. This is 180 minus pi. So 180 minus theta, this is theta, pi by 360, right? This into this minus sine theta by 2 cos theta by 2. So what is theta here? 180 minus theta. sine 180 minus theta by 2 cos 180 minus theta by 2. And this is given as twice the area of sector BOC. It is equal to twice the area of sector BOC. But what is the area of sector? It is theta by 360 into pi r square. So this is theta only. This is theta only. So you can just write theta by 360 into pi r square. Right? R square you can cancel here. So we don't have to deal with this again. So what do you get here? See, 180 minus theta. First I'll just tell you what we have to write here. Sine 180 minus theta by 2. This is sine 180 by 2 minus theta by 2. I can write it here. I can take 2 in the denominator for both of them. So it becomes sine 180 minus 2, 180 divided by 2 is 90. And this is theta by 2. So sine 90 minus theta is what? Cos theta. So this will be cos theta by 2. Similarly, with the same discussion, this will be sine theta by 2. So I'll write this as 180 minus this 180. I'll just change them. I'll just change them. So this will be 180 pi by 360, and I'll take them separately, and this will also I'll take it separately. So it is pi theta by 360, and this will be what? Minus sine theta by 2 cos theta by 2. This is equal to what? This is going to be equal to, this is 2 theta pi by 360. 2 theta pi by 360. Right? So what we require on the left hand side, this one. So I'm taking this here and bringing this on here so that I get sine theta by 2 cos theta by 2 on one side. So now sine theta by 2 cos theta by 2. What do we get here? See, this will be what? 180 by 360. So let it be like this only. Let it be like this. I'll do what? Sine theta by 2 cos theta by 2 equal by 2 cos theta by 2. I'll just write them all the way. 180 by 360 pi minus pi theta by 360, and I take this here and bring it here. So minus 2 theta pi by 360. Now I'm taking pi outside. Pi, because this pi is outside, see? So pi I can take outside. This is what? 180 by 360, this is going to be 1 by 3. So pi, and 180 by 360 is 1 by 2. Now what this will be? This is minus theta and this is minus 2 theta. So this will be minus 3 theta by 360. So this will be eventually 3 by 3 120s. This is minus theta by 120 degree. So this is sine theta by 2 cos theta by 2 equal to pi 1 by 2 minus theta by 120, and this is what was expected. This is what you have to prove. A chord of circle subtend an angle of theta at the center. So we have a chord and it is subtending an angle of theta. The area of the minor segment cut off by the chord is 1/8 of the area of the circle. So we have already the formula of this minor segment. What is the minor segment area? It is r square. This is r square. See, first of all, let me tell you what they have told. They have told that the minor segment area equal to 1/8 of the area of circle. Area of circle. So what is the area of circle? Area of circle is 8 times the minor segment area. What is the area of circle? It is pi r square. It is simple. Pi r square is the area of circle, and this is equal to 8 times the area of this minor segment, and we know the formula. It is r square and pi into theta by 360, pi into theta by 360, and minus sine theta by 2 cos theta by 2, sine theta by 2 cos theta by 2. This formula we know. Now the important thing is r square can be cancelled, and if you see this r square when we cancel, then what do we get? We need sine theta by 2 cos theta by 2 on one side, and it has 8 also. So I have to multiply 8 inside. So this will be pi and 8 pi theta by 360, and this 8 goes inside. 8 sine theta by 2 cos theta by 2. Now if you see this one we need on one side, so I'll take others on this side. So I'll just take this one here and pi here. So sine theta by 2 cos theta by 2 will be equal to what? See, I'm bringing pi here. So it will be 8 pi theta by 360 plus this. Okay, pi remains here. Pi is there. So I'm not bringing it here. Pi I'm not bringing it here. I'm just taking this on this side. So I have sin theta by 2 cos theta by 2 plus pi. So I have got the left hand side. See, 8 sin theta by 2 cos theta by 2 plus pi. So on the right hand side we have 8 pi theta by 60, and this is what? 360. What is this? 45 times, and this is pi theta by 45, and this is what was wanted. So we have sin theta by 2 cos theta by 2 plus pi. On left hand side, right hand side we have pi theta by 45. So this is what we have to prove, and this has been proved.